Lesson 3-2, solving systems algebraically. We've already talked about two ways you could solve a system, and the first one is by graphing. This method is not always the best because if you don't have integer x and y values, they're kind of hard to find on a graph. The second method will work all of the time, substitution. However, it's not always the quickest and the easiest, just depending on how the system is set up. And so we're going to learn one more method that we can use, and that's elimination. That's what this video is all about. So here are the steps for elimination. You can certainly read through them on your own. I think it's going to make much more sense if we just solve some problems together. So here's the first one. The thing you need to make sure when you're solving using elimination is that the variables are lined up in like terms, in columns. So the like terms are lined up in columns. We've got the A's in the first column, the B's in the second column, and then the equal signs are lined up and any constants on the right side. The other thing that you want to make sure of is that you have the same number in front of A or the same number in front of B. One or the other needs to be eliminated. And in this case, I noticed that I have 2B in the first equation and 2B in the second equation. So I can use elimination and subtract every column. So 4A minus 2A gives me 2A. 2B minus 2B cancels out. In other words, it's eliminated. And 15 minus 7 is 8. Now we can divide both sides by 2 and see that A equals 4. It's a pretty quick method when the equations are set up correctly. Now let's find the B value. I need to pick one of the equations to work with. It does not matter which one. I'm going to choose the second one since the numbers are a little smaller. Since A is 4, we can plug in 4 for A in the second equation and solve for B. So 2 times 4 plus 2B equals 7. 2 times 4 is 8. So 8 plus 2B equals 7. And we can continue to solve for B. 2B equals -1. Divide both sides by 2. And B equals -1/2. Okay, so it's a pretty quick and easy method depending on what you're given as your system. When you write your ordered pair, you're going to go in alphabetical order. So A goes first, that's 4, and B goes second, -1/2. Done. Now here's another one. This one's a little more complicated, and I'll explain why. So again, you need to make sure that the x's are in one column, the y's are in another column, the equal signs are lined up, and your constants are on the right side. So everything is lined up in columns. That's the only way you can use elimination. This one's a little trickier because I don't have the same number in front of x or y. So I'm not quite sure which variable I'm going to eliminate here. It's totally up to you. You can pick, but you're going to have to manipulate these equations so that either the x values match or the y values match. The coefficients, the numbers in front. I'm going to choose to eliminate the y's. So if I want to get rid of the y's, I need to find a common multiple between 7 and 2 so that I can get the same number in front of y in both equations. And the lowest common multiple here is 14. So I'm going to manipulate these equations by multiplying by a certain number so that I can make 14y in each equation. So the top equation needs to be multiplied by 2 because 7 times 2 is 14. And the bottom equation needs to be multiplied by 7 for the same reason, to make 14y. That's the variable that I'm hoping to eliminate. Now you can't just multiply one number, you need to multiply the whole equation. So let's go ahead and rewrite our system. In the top equation, 2 times 3x is 6x minus 2 times 7y is 14y equals, don't forget to multiply this last number, 2 times -14 is -28. Second equation, everything gets multiplied by 7. So 7 times 5x is 35x, plus 7 times 2y is 14y, and that's equal to 7 times 45 is 315. Now I'm ready to eliminate the y's. Now, if I have opposites, as in a -14 and a +14, I can't simply subtract every column, because -14 minus 14 doesn't cancel out. It doesn't make 0. Because they're opposites, this time I need to add the columns. So 6x plus 35x is 41x. -14 plus 14 makes 0, so I've eliminated the y's. And on the other side, negative 28 plus 315 is 287. Now we can pretty easily get the x value. Take 287 divided by 41, and x equals 7. All right, now let's find the y value. It doesn't matter which equation you work with, so I'm going to work with the bottom equation. Because x is 7, I can plug it in for x. So 5 times 7 minus 2 times y equals 45. Just following the bottom equation. 5 times 7 is 35, so 35 minus 2y equals 45. We can subtract 35 from both sides to get, oh, I'm sorry, this was a plus 2y originally. I just have covered it up with my pen. So that was a positive 2y. So positive 2y equals 10, and y equals 5. Okay, so now our ordered pair is 7, 5. And again, what this represents really is the intersection point of these two graphs. Okay, let's see what this one brings us here. The problem with this system is it's not really set up for elimination as is. It's not lined up in columns here, the x's and the y's. So we need to rearrange a little bit and line up x and y. I need to move 5y to the left side of the equal sign here. So I'm going to add 5y on both sides. And I always rewrite my system, rewrite both equations so that I can just start fresh and have everything lined up. So 2x minus 4y equals 28 is the top equation. And now the bottom equation is 4x plus 5y equals 17. Now I'm good to go. I've got the x's in one column, the y's in the other. Equal signs are lined up, and it's set up to go. Now if I look at the x values and the y values, the coefficients here, it's easier to eliminate x because I've got 2x in the top equation, 4x in the bottom equation, and if I just double the top equation, I can get both numbers in front of x to be 4. And that'll be helpful because I want to cancel out one of the letters. So again, I'm going to rewrite my system. 2 times 2x is 4x, minus 2 times 4y is 8y, and 2 times 28 is 56. Second equation, I'm just going to rewrite so that everything's lined up. 4x plus 5y equals 17. And we'll go from here. Okay, so now I have 4x on the top equation, 4x on the bottom equation. I want to subtract this time because 4 minus 4 cancels out. And I always put my operation down on the left corner here so I know, am I adding the columns or am I subtracting the columns? And in this case, we're subtracting. So here we have negative 8y minus 5y. I'm subtracting, and that's negative 13y. And then 56 minus 17, we get 39. Now let's divide both sides by negative 13. And there we go. We've got part of our answer, y equals negative 3. Now you decide which equation you want to work with here. I'm going to go into the top equation, 2x minus 4y equals 28. It doesn't matter which one you decide to use. If I know that y is negative 3, I can certainly plug it in for y in one of the equations. Now I can solve and figure out what x is. So 2 times x, this is negative 4 times negative 3, so it'll be plus 12 equals 28. Subtract 12 from 28, and we get 2x equals 16. That must mean that x is 8. Okay, so again, writing our answer as an ordered pair, we know that these two lines intersect at 8, negative 3. Okay, one more here. 8x plus 2y equals 17, and negative 4x minus y equals 9. Okay, I'm glad that everything's lined up in columns, but I don't have x's that match or y's that match. But it looks like if I just double the bottom equation, I can get the opposite here, 8x and negative 8x. So let's rewrite our system. 8x plus 2y equals 17. Multiplying everything by 2 here, we get negative 8x minus 2y equals negative 18. Now I have opposites here, 8 and negative 8, so if I have opposites I want to add, because the whole goal is to make 0 and eliminate the variable. So 8 plus negative 8 cancels out, we get 0x. But we run into a problem with the y's. If I add 2y and negative 2y, those also cancel out. So I've eliminated both variables here, and on the left side of my equation I have 0. 17 plus negative 18 on the right side, oh, this is a positive 18, I apologize. 17 and 18 is 35, and 0 definitely does not equal 35. When this happens, when you eliminate both values, but you get an equation that's not true, this means that the two lines are parallel and there's no solution to this system. If you end up getting a true statement, if you eliminate x and you eliminate y and you get something like 35 or 0 equals 0 or 5 equals 5, whatever it happens to be, then you know that they're actually the same line and there's infinitely many solutions. But in this case, we've got no solution here, and you can see why. X and y were both eliminated. Okay, I'd like you to try this one on your own. You are going to have to manipulate your equations so that either the x numbers match or the numbers in front of y match. You can choose which one you want to eliminate. So look at 3 and 4 for the x's, or look at 4 and 5 for the y's, and decide how can you get them to match so that you can subtract the equations and cancel them out.